We're always tempted to think that a really short problem means a really simple answer, but you know, there's never any guarantees like that in reality. This particular problem is a good example because it's very short, but working it isn't necessarily simple. A gift shop sells 400 scented candles a year. Okay, that's nice. One of the things that I notice is a year, that does sound like it is annual demand. That's the little note I wrote to myself, capital D equals 400. Right, because then the ordering cost is 60. You know, that's usually our typical symbol for the fixed cost of placing an order for scented candles, and holding costs are $24 per box per year. Oh, you know, that's the definition of H, the cost of holding one unit in inventory for 1 year, 24. What is the minimum amount these combined costs the gift shop could pay? Now, we are looking at this problem. Oh, simple, you know, I see it's the EOQ, you know, minimizing ordering and holding costs. This is the EOQ that's forming up here. Because I have everything that I need to calculate the absolute perfect order size for scented candles. That is 2 times D times S divided by H, except I've got to take the square root. All right, well, for scented candles, 2 times 400 times 60 divided by 24, I get that's the square root of 2,000, which comes out a little messy, like 44.72 some odd. The EOQ is an order size. I mean, it's got to be number of boxes of scented candles, and there's no such thing as the 0.72 boxes of scented candles. So, fair enough. The absolute perfect order size, the EOQ, for this gift shop would be 45 boxes of scented candles. When you need scented candles, always order 45 boxes. Why? Because that will minimize your combined ordering and holding costs. Now, maybe I shouldn't have drawn a box around that, because that's not actually the answer to the question. It's good, we need it, but it's not the answer to the question. Because what the question asked is, what is the minimum annual amount of these combined costs, meeting the ordering and the holding cost, that the gift shop could hope to pay? Now, the EOQ is an order amount. Order 24 boxes in order to minimize those costs. But the 45 is not telling you anything about those costs. It's just telling you the number of boxes of scented candles. Oh, right. So for this little short problem, actually, we did need to work the EOQ. We need that 45. We needed that formula, and then we need another formula on top of that one. Because now that we know what order size will minimize their combined ordering and holding costs, we have to calculate what those actually are. So what we need is the total cost formula, in this case, D divided by Q times S plus Q divided by 2 times H. This will calculate their annual ordering costs. This half calculates their annual holding costs. Add them together. That is their combined costs. If you use Q equal 45, that will minimize their costs. That's the whole point of the EOQ. Oh, all right. So let's do that. Okay, D is still 400. We have just decided their Q will be 45 because that will minimize these costs. Okay, fine. S is 60 plus 45 divided by 2, Q divided by 2 times the 24. I get 1,073 and some odd cents. When I put that in my calculator, $1,073 and like 33 cents. Okay, that is the combined cost of using a order size of 45 boxes. That's what this formula tells you. We know that this is the minimum combined cost, which is what the question asked for, because the 45 is the result of the EOQ, the other formula. That's what it does. It finds that one perfect Q to plug in here that when you fill this out again, finds you the smallest number here.